NASA 557, contact tower 128.15.
Caution, caution. Manual, fuel, manual, fuel.
I'm John Goglia.
I'm Greg Fife.
And I'm Todd Curtis.
And we are the Flight Safety Detectives.
Between us, we have over a century of aviation accident investigation and safety experience to draw on as we discuss issues that affect all of us.
So we are qualified to share our perspectives on accidents and incidents and what can be learned from them for the future.
We're proud to say that we have two sponsors that really relate to the topic of aviation safety: the Professional Aviation Maintenance Association, or PAMA, and Avemco Insurance. Later on in the show, we'll tell you how you can get a 5% discount on your insurance just for listening to the show.
We don't just dissect the official reports. In every episode, we identify safety issues and take the mystery out of accident investigations.
So maybe pilots and their planes can have safer flights ahead.
Well, hello, Todd.
Well, good afternoon to you.
Here we are. We're in the same city, at least.
For the time being, not for long.
Yeah. Same general city, I should say. We're 30, 40 miles apart, I think. But in any event, it's a beautiful day here in New England. And we've had a lot of comments on our chat pages, including, people have found my phone number. Look, my phone number's been out all over the world. But some of our listeners and watchers have found my phone number. So I'm getting a lot of direct calls on what we said or what they want to see us talk about. And that's fine. That's fine. My phone rings constantly as it is. It doesn't matter. But anyway, we had multiple conversations with some of our listeners about the SpaceShip accident out there in Nevada, in the desert. And so I asked you to take a look at it, as I did, and we've come up with a lot. And there's an awful lot in the NTSB report. There's not a lot of recommendations. They're a little light on the recommendations, but there's an awful lot of good information in the report. And a couple of the people that I talked to directly are pilots. So they had a pilot focus on what was going on. And I thought we could never cover this accident in one podcast, even if we do an hour-long one. It's too much. So I thought just today we would talk about the human factors issues in experimental aircraft and assumptions made by the engineers who are not pilots often, and the assumptions made even in the cockpit. So I know I've asked you to take a look at that. I took a look at it myself, and I don't want to hog all the time. So why don't you talk about the piloting side of this report?
Well, I'll give a very quick thumbnail sketch of the event. This happened in October of 2014, a little over 8 years ago. It got plenty of press attention, and so I won't go into those details except to say that this was a Scaled Composites, is the company that was building what's called SpaceShip 2 for the Virgin Galactic Company, to take passengers into the lower reaches of space. It was designed to be dropped from one aircraft, launched into the lower reaches of space with its own onboard rocket, and then glide back to a landing. And one of the unique things about this spacecraft aircraft hybrid is that during reentry, in order to slow the spacecraft down and not have it overheat from atmospheric friction, you had the system where the tail end of the aircraft would come up I think they call it like a shuttlecock, like a badminton ball, in that it would help to slow the aircraft down. Now, that slowing of the aircraft is caused by aerodynamic forces on the surfaces as it re-enters the atmosphere. In order for this to work, it had to be deployed at a certain part of the flight. And during this test flight, They had launched from the launch aircraft, had hit the rocket. They were about 10, 15 seconds into the flight. And the test called for the system to be unlocked once the aircraft passed a certain Mach number, I believe Mach 1.2. Instead, for reasons that we'll get into later, the pilot, one of the two pilots, unlocked it early. And as a result, the aerodynamic forces that came before maximum dynamic pressure caused the system to deploy. It got torn apart by the aerodynamic forces, and there was a loss of the spacecraft. One of the two pilots was able to survive. And in the aftermath, the NTSB looked at many factors, and the part that we're going to focus on is human factors. This was a flight test event, and apparently there were, let's just say there were gaps in the assumptions made by all involved with respect to how to go about with this test. One of the big assumptions was, or big gaps was, there was quite a bit of attention paid during the development to failure of the system to deploy prior to reentry. Not as much attention paid to accidental deployment at an improper time, which would be caused by the crew, because this was a manual deployment system. This was not an automated system.
No. As a byproduct of looking at this accident, I went back and looked at a couple of others with airplanes that had been certified and had problems. So they were in the same place in development as this airplane was. It's not certified for sale, but it is, the FAA is blessed it to fly as they do their experimental work and develop all the processes that they need to make a good airworthy airplane or vehicle. But I went back and looked at a couple others that involved later generation, i.e. newer airplanes, newer companies as well, designing and flying airplanes that had accidents during the certification process, during this period of testing, and to take a look to see if there's anything common in what I read, not the recommendations, but what I read about this accident and what I read about the other two. And one of the things that jumped out to me was that you have all these engineers, all these different disciplines designing the airplane, and they go into great lengths and they coordinate with each other greatly in order to put the package together in an efficient manner. And there's a lot of assumptions made when it comes to the crew that's going to fly the airplane. These engineers, sometimes working with their chief pilot, sometimes they're not working with the chief pilot, but they're making assumptions and building things into the airplane or the vehicle to help make it safer. But in all of these cases, the three that I looked at, in all of the cases, there's something missing there. And I'm not ready to jump off the bridge and say what it is, but it's obvious that something's missing, because in the front end, we've got all this talent working on it, and it's inside the facility, so there's not a lot of information that you and I can access. All right, but then when it comes out out of the factory and into the operational side, we're seeing the common denominator is problems with the pilots. Lack of procedures, lack of coordination, all the basic things that we have seen in other accidents. But it seems like they were not addressed, obviously not adequately, but did they get the attention inside the factory with the design team that they really needed to get? And, in a quick brush, and I hate to do that because there's some speculation involved, but it certainly looks like there's something there that needs to be looked at the very least. So that the FAA needs to pay a little more attention, closer attention to what some of these companies are doing. And admittedly, the FAA's got a very tough job, because all this technology and all these systems that these companies are putting out are breaking new ground. And these engineers and all the other people inside the factories in the design centers, they know far more than the FAA knows. And it's really a disadvantage for the FAA to have to come in and have to try to tell them what they're doing wrong. And the FAA's got to bless it for them to go to the next step. So it's really, really a challenge for the government to stay on top of industry. Plus, I long said, including when I was at the NTSB, that it's not possible for government to keep up with the speed of business. We have all these smart people moving forward, working in their own cubes inside the buildings where the FAA has limited people with knowledge, limited access, and they're developing systems and processes, and then they bring them to the FAA for approval. And the FAA is really at a big disadvantage. And that came out on the accidents with the MAX as well. It's not just the space program that has these problems. It's also the aerospace industry. Embraer, Airbus, they've all had the same problems with the certification side. Airbus has been a little better because their people and the government people tend to be either work together or change jobs. So Airbus people go inside the government and vice versa. But in any event, however they get it done, that's still an area that needs to have more light of day shined on it, more attention by the government. And so that's just the first part of this. And when we get into the cockpit on this accident airplane, I know you went over the human factor side in the cockpit, and I'd like you to restate that part about the design people and what they did and the time lapse between what they did and the accident.
And the report that came out was a traditional major accident report that you would see for a commercial airliner. And by the way, this is the one and only commercial space accident that the NTSB has in its accident database. So this is a jumping off point for anyone who wants to get into understanding how difficult it may be to do this kind of thing and what are the challenges they might face. And the human factors portion of this accident report was only a couple of pages long, but there was a lot packed into it. Basically, they were saying at Scaled Composites, although they were building it for the Virgin Galactic Company, it was still a flight test vehicle. It is still the first of its kind. And they're an R&D company. They put a lot of effort into looking at how the system worked. They did not put as much effort into how the human beings work. And this is a quote in the report. The former chief aerodynamicist stated that the feather system, which is the system that had the aerodynamic failure, the feather system mitigations were more for a failure of the feather system to unlock and not pilot error. And again, that simple oversight, that is working with their expertise, which was the system, and not on the pilot side, worked well enough up until that point, because there had been a previous version of this kind of spacecraft, SpaceShip 1, which had been flying for some years, and they'd had success with flight tests before then, and there had not been any major failures, any major accidents. And the other thing, right after that, SpaceShip 2, the accident spacecraft, was being developed for eventual use by pilots who might not have test pilot experience. And the design approach should have focused, says the NTSB, should have focused both on the reliability of the vehicle and the human factors involved. Again, not something that is unique to space flight development, spacecraft development. Flight testing is done by flight test pilots, flight test organizations. Everyone involved in the organization on average have more experience, more insights than what you would see in the average line operation. Doesn't mean that you'll have incompetent pilots flying, but in general, test pilots are going to be toward the high end of the distribution of talent, and pilots in the field are going to be the normal distribution of talent. Doesn't mean they're incompetent. It means that you will have certain kinds of mistakes, certain kinds of errors, certain kind of problems in a general population that you don't see in a flight test population. Not only different kinds of problems, fundamentally different kinds of errors that a highly trained, highly experienced person would make versus someone who is not. They would still make errors, but very likely different kinds of errors. And on the timing, that is, of the pilots who were in this particular accident flight, the same report mentioned that there was the only documented discussions involving the accident pilots about the loads on the Spaceship Two's tail occurred more than 3 years before the accident. And those discussions, again, like the chief aerodynamicist said, assumed a system failure, not pilot error. So, as competent as these pilots were, as experienced as these pilots were, they didn't have any documented evidence of being trained or made to understand what are the various kinds of failures that can happen in flight.
Yeah, and they weren't trained in CRM as well, were they?
And now it was something where, and one of the basic tenets of CRM is one pilot does something and the second pilot in the cockpit checks that that pilot did what was supposed to be done. And it would appear from the report that the actions of the pilot flying and the other pilot were somewhat uncoordinated. And they certainly were uncoordinated when it came to the feather system being unlocked well before it should have in the flight, in the particular flight they were doing. Now, another point on commercial space operations. I won't go into the history of NASA and other programs of that kind, but 30 or 40, 50 years ago, there were governments who ran these rocket programs, these space programs. They might have used commercial partners, Boeing, Lockheed, et cetera, to help build it, but it was the government that owned it, the Saturn V, the Gemini, et cetera. Moving to the current era, you have a variety of commercial entities right now that are launching payloads and people into space. You have SpaceX. You have the New Shepard rocket from Jeff Bezos's company. You have various companies that have launched cargo to the International Space Station, although not people. And you'll have other companies come up the line as well. Many of them have quite a different kind of flight profile, a flight vehicle, than you see with Scaled Composites. Scaled Composites is designed to be launched from one aircraft, go up into space, land on a traditional runway. That's not what SpaceX is doing with their various vehicles. That's not what Boeing is doing with their Starliner. That's not what anyone else is doing. Not even the New Shepard rocket from Bezos is launching and landing like this. So in this particular report, where the NTSB recommended that the commercial space industry look into doing things differently, and I want to get this quotation right. This is in the recommendation section. There were 2 recommendations to be made that they made to the commercial space industry. The most relevant one, and I'll read it verbatim: work with the Federal Aviation Administration to develop and issue human factors guidance for operators to use throughout the design and operation of a crewed vehicle. The guidance should address, but not be limited to, the human factors issues identified during SpaceShip Two's accident investigation. And without belaboring the point, we've all seen SpaceX launch crews into space on their Dragon capsule and Falcon 9 booster in the Dragon capsule. Not at all designed like what Scaled Composites did. We've seen the New Shepard vehicle from the Jeff Bezos's company launch people into suborbital spaceflight. Not at all designed like what SpaceX is doing. Boeing has a Starliner, which has had an uncrewed test flight, will soon have a crewed test flight. Very much like a traditional space capsule, sort of like what Boeing has been doing off and on for decades. But again, unlike what Scaled Composites has done. There will be future commercial space vehicles, some of them with people, or human rated rather, likely will not be anything like the Spaceship 2 design. So this is a nice recommendation from the FAA. I agree with that recommendation, but the practical considerations are these companies are in a highly competitive business where the rate of failure is high. Those companies I mentioned have actually put hardware into space. Many other companies are still in the stage of, yes, we're going to do it one day soon, or they flamed out and are no longer here. That will be what commercial space will be like for years to come. While the model for making money in space is ironed out by people, you'll have a lot of systems that are on the drawing board, some that'll get the flight test. Not all of them are going to work. And in my opinion, most of them will have quite a bit different kind of human factors issues than you would see with compared to, let's say, Boeing versus Airbus developing an aircraft. the kind of human factors issues that happen in commercial aviation have been worked on for decades. And even if you have completely different companies making an aircraft, it's going to be very similar in design, very similar in the kind of avionics, very similar in the kind of training. People who fly on one model of aircraft can can learn how to get used to the systems on a different manufacturers and fly it. It's not going to be the same with space.
Yeah, you raise an interesting point that I was thinking of as you were speaking, and that's the space shuttle. And I don't know how much most people out there realize, but the space shuttle really is a completely autonomous landing. There are various points in the re-entry process where the astronauts on board throw switches. Not a lot of switches, just a few. And I was told in one of my visits down to Kennedy Space Center that the whole purpose of that is to keep the pilot's head in the game of the airplane landing, keep them engaged so they stay focused during the landing. It's entirely not necessary. They could have designed that system to hit those switches all by themselves. So they didn't need the pilot to do that at all. They just did it in order to keep the pilot in the loop. At least that's what I was told by one engineer. I assume it was true because when I listened to their actual physical activity, there's not a lot they're not controlling a lot of the landing at all. So in any event, Virgin here may have, or space scaled composites, may have been better off if they fully automated that system and kept the pilots out of it. But that's Monday morning quarterbacking on my part, and with really not all the knowledge that I probably need to have to make that kind of decision. But today there's a big push to try to take the pilots out of commercial airplanes, out of the cockpits. And I suspect they're going to be successful with some of that in the not too distant future, especially for cargo. I think they're going to be successful on that side of it. And I think that on the space side, we're going to see there's going to be no pilots on the spaceships. There'll be computers telling them where to go and how to get there, and setting the machine up to make that happen. So there'll be people programming the computer, so to speak, and not actually flying the vehicle.
This is getting a bit beyond this particular accident, but you're bringing up a point about the commercial applications of commercial space. One of the reasons that you had something like a space shuttle design, and there are also miniature versions of that kind of vehicle being flown right now for Air Force missions, and in that you can have a winged vehicle fly in space and land on a runway. Makes it very easy to recover, as opposed to having a flotilla of ships out on the ocean, or having a specific patch of empty land where you can only land it on one place. Space shuttle, in fact, could have landed on any number of runways around the world, so long as they were sufficiently long enough. And I think, in my opinion, that there will be some commercial vehicles out there that will be designed to land on traditional runways. Will they need to have pilots to do so? No, that's been demonstrated. Heck, it was demonstrated back in the 80s. I believe it was the 1980s when the Russians flew their version of the space shuttle. They only flew it once. It's a test flight, one orbit around the Earth, I think it was, or less than a day in orbit. It landed autonomously. This was using technology that's 30 and 40 years old. So yes, it can be done. Likely will be done.
Yes, interesting piece. But here again, we're faced with engineers that don't put enough emphasis on the human being in the machine. I mean, that's what the FAA is saying, the NTSB is saying with human factors. It really is the emphasis on the human being, understanding the mistakes that he could make, the failures of the human being. We all make mistakes. We all have failures. Now, virtually every day we do something in our life that requires us to do it over, or it's just an insignificant event that we just continue on with. We don't have insignificant events in air travel, whether it's spaceship or airplanes. So it needs to be considered. It never used to be. We've got it now Boeing and Airbus and the commercial airplane manufacturers have a lot of people engaged dealing with those issues, and they still miss things. So to have it totally ignored by this space company and maybe others is unacceptable. We as the collective industry have to push hard and make sure that the lessons learned from this 8-year-old accident are not lost, because what came out of the report, the recommendations are pretty weak, and the FAA, like I said, is behind the curve on what's going on behind closed doors in a lot of these companies. So it's going to take a lot of work by a lot of people to clean this problem up. All right, so I think that we've chatted enough about the human factors piece, because we're going to be back into it again as we walk through the other 6 or 7 areas of interest from this event. So this will be, I don't like labeling part 1, part 2, but this will be one of the early dissections of this particular accident. So all our listeners can expect 2, 3, 4, 5 more limited dissections of this accident to highlight the individual areas that need to be talked about, more than just 1 or 2 sentences that are in the recommendation section of the report.
And this is not a theoretical sort of exercise just to look at this particular event. This is something that will get us ready, in a sense, for what will happen in the future. There will be many more commercial space operators and commercial space operations in years to come. And when things happen, as they inevitably will, we'll learn something different from them. And one of the things I'm looking toward is, are there going to be some commonalities to these programs and these accidents when they do happen, such that there could be lessons learned that could be applicable across the board, not just in space space transportation, space flight, but in commercial aircraft transportation.
Yeah, what's interesting on all this is a lot of professional people in aviation laughed at Musk when he said about recovering his rocket. And last year, I think it was 52 or 53 of them he recovered without incident. I mean, it's really amazing. It's really amazing. There's no pilot on that. It's all computer. It's monitored on the ground, but it's all computer controlled by the vehicle. So in any event, we are going to have much more to talk about. So Todd, I'll give you the second to the last word.
Well, the one takeaway I have with this is, for those of us, especially older folks like us who grew up space being this fantastically complex thing that only rocket scientists can do. Well, yes, rocket scientists are still doing that, but so too are people across the aviation industry. Many of the maintenance professionals not many of them, but there are many maintenance professionals, some of whom we've met, who started off in traditional maintenance and immediately went over into space. In fact, I work right now with Vaughn College, and I remember reading a notice in one of their news bulletins that SpaceX was coming there at an event, and they were looking to hire people with no previous aviation maintenance experience other than getting their A&P certificates from the FAA. So basically, right out of the gate, instead of going in their planes, they're going into spacecraft. This is not the future. This is the present.
Yes, and we have a number of students from the aerospace maintenance skills competition that have gone to work for the space industry right out of school. And in fact, last year, I remember they hired, one of the companies hired the entire graduating class from one of the A&P schools in Florida. So the entire class went. In fact, there was a launch where we actually saw one of the competitors from 2 or 3 years back was closing the hatch on one of SpaceX manned launches. He was the last person to touch the vehicle before the launch. So it is an exciting time for a lot of the young people. In fact, sometimes I wish I was younger to go back and do some of that stuff myself, because I've been a space junkie my whole life too, like many other people. All right, and at the end here, I'll say it again because I keep looking at accidents and just shaking my head. If you're going to go fly, please do a good job of pre-planning your flight, including your weather I mean, the weather has become so visible in the accident sequence that the FAA has now given a grant of a bunch of money to NAFI, the flight instructor trade group, essentially, to study what the CFIs are delivering to the students in the form of weather. So they're trying to identify if it's the problem with the training syllabus or if it's the problem with the learning. So that's the first step in trying to get a handle on the weather issues that many pilots fail to get right. And we have accidents, we have incidents far too often involving the weather. And some of it you can contribute to the weather being unpredictable, but some of it you just got to shake your head and say, what were the pilots thinking doing what they did? So please do a very good job of pre-planning, including the weather, you know, where you are, where you're going, and everything in between. When you get out to your airplane, do a good pre-flight. You know, things happen to airplanes sitting around. You know, if it's sitting around too long, you got likely going to have birds in the engine, bird nests in the engine. You're going to have pitot tubes full of little bugs. The list goes on and on. So you got to pay attention on your pre-flight. And then after you get in the air, please put that head on a swivel, look around, mid-airs are happening. We're going to do a program, maybe the next one or the one after, on the mid-air that occurred out at Centennial in Colorado, in Denver, Colorado, which was a miracle that the folks walked away from that. If you look at the picture of the Fairchild, I mean, almost the entire middle piece is missing. It's amazing that the airplane stayed together. So another Aloha Airlines type, where most of the airplane's gone, but it didn't break up. So we're going to be doing that one in either the next show or the one after. So please put that head on a swivel, look around, know what's going on around you, and fly safely.
Thank you for checking out our show. We really value our listeners and subscribers. Our podcast gets ranked by you and how much you like it. So please give us 5 stars in your podcast platform.
We want to keep in contact with you. We are on Facebook, Twitter, Instagram, and of course, YouTube.
You can email the show at flightsafetydetectives@gmail.com. By the way, if you're on YouTube, we're really working on growing the channel, and it helps if you all send in comments. Please do that, and we read all the comments.
And be sure to subscribe. Remember, if you're in the market for aviation insurance, you can save 5% with Avemco just by mentioning our show. Visit them at www.avemco.com. That's it for this episode of the Flight Safety Detective. Until the next episode, fly safe.